Hi, today we're solving problem 51. By replacing the first digit of the two-digit number *3, where star would be replaced by a digit, it turns out that 6 of the 9 possible values 1, 3, 2, 3, 4, 3, 5, 3, 7, 3, and 8, 3 are all prime. By replacing the third and fourth digits of 5, 6, star, star, 3 with the same digit, here we get a family of 7 primes among the 10 generated numbers. We need to find the smallest prime, which by replacing part of the number, and these don't have to be adjacent digits, with the same digit, it needs to be part of an 8 prime value family. So the way we're going to solve this problem is we're first going to pre-calculate all primes under 1,000,000 as an upper bound. Then we're going to go over each of the prime numbers and see in which ways could we keep some of the original digits and replace other digits with the same values. So we pick which ones are going to be replaced by stars. Then we're going to iterate over these and find the first one that has 8 primes within that family. So let's get started. I'm going to switch over to IntelliJ. Now the first thing we need to do is be able to generate, given a number of digits in a number, we need to know which ways could we put stars in different places. And we're going to solve this recursively. What I'm going to do is create a def ways to pick. We're going to take a number of digits of type int, and we're going to be returning a sequence of Boolean. So we're going to give a Boolean. If the Boolean is true, that means it should be replaced by another digit when we're replacing values. If it's false, that means we should maintain the original digit. So now what we want to do is first we need to have an edge case, which is if digits is equal to 0. When digits is equal to 0, there's only one way to pick, which is don't pick anything. So I return a sequence, and this has one way to pick, which is just an empty sequence here. Otherwise, what I want to do is I want to recurse by first picking with digits -1, and for each of these I want to generate cases where it starts with a true or it starts with a false onto this. So I'm going to flat map this. Given a picking, how we're going to pick, I'm going to create another sequence. The first one is going to be true appended to the picking, and the second one is going to be false. So here now we're basically just branching out, seeing, okay, true or false, and here true or false. So in that way we generate all of the ways to pick. Now the second one is, given a way to pick, how do we replace the picked digits of a number with a certain digit? So I'm going to do def replace in number. It takes a number of type int. It's going to take a digit to replace with of type int. And lastly, it's going to take a picking, which is going to be a sequence. Oh, whoops, what's that? Sequence of Boolean. Now, given these three, what we want to do is first we're going to convert num into a string so that we can zip that with picking. If we convert num into a string, we get a sequence, and then we can just match up the values with the values in picking to see which ones I need to replace. So I'm going to first create a num string. It's going to be num.toString. Now what I'm going to do is I'm going to take my number. I'm going to, num string actually, I'm going to zip that with the picking. So this will give us a sequence where we have first a character, which is the digit, and then a Boolean, which is whether or not to keep it. And now I'm going to map each value of this. So we're given I can do a case. So the first one is original, second one is replace. And if we want to replace, then I'm going to replace it with digit. Otherwise, I want to keep it, so I'm going to take original, and I'm going to turn it back into a digit, which is going to be an integer here. So actually, I'll put this on the next line. So now we get a sequence of integers, and these are each of the digits. But to get back a number, what we need to do is first convert this into a string with no spaces in between using mkstring, and then do toInt to get back a number. So I can test this out. I can replace a number. Let's do 1, 2, 3. Our digit is going to be, let's say, 5, and our picking is going to be a sequence. Let's replace the first and last. So true, false, true. Now if we run this, we should get 5, 2, 5. And we get 5, 2, 5. So we know that replace a number works. Now the last step is going over the prime numbers and seeing which ones can be replaced so that we get a total of 8 primes. And the first step of that is calculating all of the primes under 1,000,000, which we decided to be our upper bound. So I can create a val all primes is going to be util.sieve. So I'm using the sieve of Eratosthenes here to get all of the primes under 1,000,000. Now I'm also going to need to iterate over all of the primes, and I want to do this starting from the lowest prime because they care about the smallest prime here. So I'm going to create a val all primes sorted, which is going to be my all primes. I'm going to convert this to an array, and I'm going to get a sorted version of this. So now that we have sorted primes, we can start iterating over them. What I want to do is I want to find the first value in all primes sorted such that we get those 8 prime numbers. But I don't care about calculating values after that. So I'm going to create a val answer. What I'm going to do is first is I'm going to convert all primes sorted into a view. Now by calling .view, I'm getting a lazy collection. So we only calculate values that we need, and we don't calculate any further than that. So with this, as soon as we find a value that works, we just go ahead and return that. Now, given a view, I'm going to flat map. I'm going to take the base prime, so the prime to generate values from. The first thing I need to do is calculate the number of digits, which we'll need to calculate the pickings. So I'm going to create a val digits. I'm going to calculate this by using log base 10. So the formula will be math.log 10 of our base prime. So in the case of 100, that would give us 2, and any value between 100 up to but not including 1,000 will give us some value between 2 and 3, but we know all of those are 3-digit numbers, so what we do is we round this down and we add 1. And this gives us the number of digits in our base prime. Now what we want to do is go over all of our pickings. So what we want to do is ways to pick is going to take our digits. Now given all of our ways to pick, we don't want to include the cases where we don't include all of the digits or we do include all of them. And these end up becoming at the first element and the last element are these cases, because the last element will be where we have our false all, and the first element is where we have all trues. So what I'm going to do is to knock out those cases, I'm going to do .tail.init. Now given all of these ways to pick, I'm going to flat map over these. What I want to do is I want to take each picking and see if there are 8 primes that can be calculated with this picking. So what I'm going to do is, given a picking, I want to do first, I'm going to check if I can replace and find 8. So what I want to do is I'm going to do if, and what I want to do here is take all the current picking, So what I want to do is, here I want to first replace in the number, or actually that's not what we want to do. We don't want to go over the values in each picking. What we want to do is we want to count for that ways to pick. So actually, I don't know where I was going with that. So given all of my pickings, I want to see that the number of pickings that produce a prime number should be equal to 8. So given a picking, I want to make sure that replace in number, we're going to start with our base prime. And here we need to make sure that for each of the digits, I know where I was going with that. Okay, so let's go back. So what did we have? We are given a picking, which only tells us which values to keep and which values not to keep. But that doesn't tell us which digit we're going to replace. What we want to count is how many digits produce a prime number with that picking. So what I'm going to do is I'm going to need a count such that 1 to 9, so these are our digits. I need to count the ones such that when I'm given my digit and I replace in the number, so I start with my base prime, I take my digit, and I have my picking, which is a sequence of Boolean. I need to make sure that this value is part of all primes. So I need to check all primes dot contains this value. And this will give me how many of these values are prime. Now I just need to make sure that this is equal to 8 because we want a... Because if we go over to Project Euler, here it says we want an 8 prime value family. So here we're checking if it's 8. If we do have 8, I'm going to return a value with the first value of picking, because the first value of picking might not necessarily be the base prime that we started out with, because we are going to be replacing digits from that. But I know that the lowest value is going to be the first element of the ones that work. So what I'm actually going to do is I'm going to take this out. I'm going to replace this with a filter. I'm going to create val picked primes. So these are all of the primes that work here. I need to make sure that picked primes is of size 8. And if it works, then I'm going to return the first picked prime. Otherwise, I'm going to return nothing. And here, by flat mapping, I'll get all of the picked primes that work here. But now I only care about the first value of this that works. I'm just going to do head here. Or actually, I don't even need to do head here because we're flat mapping on this value. So this whole thing will give me all of the picked primes dot head for every single way to pick and for all the base primes that we search for. But I only care about the first picked prime that works. So I'm going to do dot head here, and that gives us our answer. So now I can println our answer. And I can go ahead and run this. So right now it's going to be generating all of these primes, and we get 1. That's interesting. Let's go ahead and debug this to figure out what happened. What I'm going to do is I'm going to, at every step, println all of our picked primes. So let's go ahead and run this. Oh, okay. So whenever we have our picked primes, looks like we're only getting 1-digit values. Why are we getting that? Well, let's println our digits, because that tells us how large our picking is going to be. So I'm going to println our digits, and this should be increasing over time. Yeah, it does seem to be increasing. Here we have 5, here a 5. Well, it's a 5-digit. Let's see what's going on. So what I'm doing is Here, maybe I can print ln our picking to make sure this is right. Okay, so we do seem to have good pickings here. Now what am I doing here? I take my base prime, I take my digit, and okay, what I'm going to do is I'm going to temporarily print 1 to 9, and I'm going to map into this. And I'm going to just use underscore here. So I'm going to find all of the replacements and see if that looks good. I don't need to do a contains here. That's it. Now if I run, I should see the picked numbers. Yeah, so we do seem to have 2, 1, 1, 3, 1, 2, 2, 3, 2, 2, 3, 3, 3. Okay, so why are we getting 1 here? Aha! Okay, I figured out exactly what went wrong here. What we're doing is what we were trying to do was find a replaced number such that this digit will work. But what we're actually doing is we're finding only the digits that work here. So what I want to do is I'm going to do it this way. I'm going to first map it. So this gives me all of the replaced values, and now I'm going to filter the ones that are prime. So I'm going to do all primes.contains. And now we should be good. Now if I run, and we get our answer. So we should probably stop printing that. And now if we run again, we have a pretty fast answer. So what it starts out by doing is finding all of the primes under 1,000,000, which is where it spends most of its time. But after that, it's a quick search and it gets our answer, 121,313. So that's it for problem 51. I'll see you next time when we solve problem 52.